Hello everyone, my name is Clarindo and I will present the environmental wave contours for the west coast of Fuerteventura Island. Here I will present the summary of the work. I prepare in some topics that consist in an introduction, present the main goals of the work, a study case, description, the environmental wave contours, and the main steps to compute the contours, the results, and the main conclusions of the work. The wave energy today is considered a clean, practical, economical, and environmentally friendly as well. In addition, it's highly recommended as alternative and future source of energy. And to design a marine device, we require several simulations until achieve the safe levels, and of course these levels have to be tested, mainly against the wind and wave load. So, to effectively design a marine structure such as a wake device, we need as minimum information about height and period of the waves, and as well the joint probability of occurrence for a specific area. The main goal is derive a sea wave contours for a grid point in the west coast of Fuerteventura Island, and then 5 extreme combination are extracted for marine design purpose. These grid points are considered a hotspot of energy in this area and presenting a vital wave energy distribution over the year. How we do this? We follow a standard recommendations such as the NVGL for this task, and basically consist in identifying extreme combinations along the contours, and is widely useful for our kinds of engineering application in order to model metocean distribution and of course to achieve our goals. 2. Description of the study case. Fuerteventura, as all islands from Canary Archipelago, are fossil fuel dependent for energetic needs. Just few percent from renewable sources, mainly from solar and land eolic. Moreover, the low precipitation of the year make the islands 100% dependent of desalination activity for freshwater supply. Thus, how the population are increasing, the number of the seawater desalination power plant also increase, resulting in energetic demand problems. Consequently, the activity by seawater desalination, which is vital for the life, of course in these days represent a high level of energy demand in comparison to the total consumption of the island. And this local impact of energy consumption can be or may be alleviated using implementing wave energy to supply energy for desalination activities. The Fuerteventura case is not an isolated case. This is an ordinary problem from islands with high energy demand, fossil fuel dependence, high tourism activity, and others. The interest for this kind of resource are increasing over the years. Some results are evidenced. Islands with important wave energy power production. Here we can see some important islands around the world and studies about the wave energy power potential. And also we can see in the Canary Island context the relevant results about this topic. We will pay attention in this last one in 2016 that is consist in assessment of wave energy power production in the west coast of Fuerteventura, our target zone. This study provides results about the distribution of the resource in the west coast of Fuerteventura and take into account this distribution. We will identify our grid points. Here we can see some trends about the energy over the seasonal, and we can identify three different trends in average terms, allowing us to divide the island in three sectors: north, central, and south zone. The dataset analyzed corresponds to three hindcast data, spatial well distributed in the west coast of Fuerteventura. We will consider significant wave high and peak period from on our sea states. The global data corresponds to 44 years of the data, and the provider is Port of State and Coastal Authority from Spain. The wave contours are computed for 20 and 100 years of period of return. The environmental contour methods. These involve three main stages that consist in 1. Model statistically the metocean observation and apply some suitable distribution to model them. Second one consists in construct the contour based on the previous joint model. This step is made by a form approach, but I want to say here that exists other approach such as direct Monte Carlo sampling, copula sampling, rejecting sampling, and others. And the final step consists in select the critical points along the contour to apply and design structure application and for marine purpose. Usually, the first step of contour derivation are the model, the joint distribution of the variable or metocean variable considered. So we use a conditional modeling approach that consists in model the marginal probability distribution of significant wave height using three parameters of Weibull: shape, scale, and location, and the conditional TP distribution based on log normal, and the statistical dependency are based on the mean and the variance of the distribution. As you can see in this formulation, and each variable are conditioned by the statistical parameters. The last two ones are the TPE, periods dependent of significant wave height, and we have three free parameters for each one. And then the conditional scheme are done. For more details of conditional modeling approach, please check this reference. The step 2 consists in construction of the contour. In these days, for this task, we have different approach. However, we will apply the I-form contour. This approach is a recommendation of the international standard certification, such as Electrotechnical Committee. In short, to design Marine energy devices, they recommend extract extreme points along the contour using a form approach. And this is exactly what we do. To construct the contour using a form method, we have to perform these two main steps. The first one consists in the estimation of these two important parameters to construct the contour. That is saved index and the probability of failure. So firstly, we have to estimate the probability of failure using this equation. There is a relation about sea state duration. Remember, the data cadence is 1 hour and return period in years. And then we can establish the relation between saved index and probability of failure using this equation that consists in the cumulative density function of the saved index estimated previous. The second step consists in the transformation of the variables, because firstly we operate in the normal or imaginary space using this relation, using the saved index. And then we have to transform to physical space or the variable space. And then we have to perform the Rosenblatt transformation that consists in transform the variables in U space to X space. That is, they have a physical means. In this figure, we can see clear how to perform the transformation using Rosenblatt. So for final steps that consist in design points, we have to consider the 20 years of environmental control lines, and then 5 extreme points are extracted along the contour, or is the same, the 5 coordinates of points. So these combinates of points can be applied to design a WEC structure in marine purpose. And then the highest values of significant wave height and the correspondent TP are extracted. Also, the highest value of TP are also extracted, and of course they associated significant wave height. The criteria for selecting critical zones are based in several simulations of Monte Carlos that is consistent in artificially simulating several points based in the joint model considered in the first steps. So this is allowing to identify which zone will contain exceedance of sea states, and then we can characterize the failure points. The result section beginning showing the fitting of the distribution for each point. In this figure we can see the hindcast conditional fit for sea states considered. The parameters are estimated by maximum likelihood estimations, and in this table we can see the parameters considered for each of them. Here we can see the final results that represent the sea waves I-form contour established for 20 and 100 years of return period for each point ABC, and also the reliability saved index with the probability of failure for each year period of return. So in this session we present the results from criteria applied to select design points. So first we consider the 20 years return period and the contour lines following the NV recommendation, and then using Monte Carlo we simulate several points based in the fitted joint model on the first step of contour construction. And then the maximum values for each variable are considered. Here you can see in the red points the 5 points for the maximum significant wave height, and the blue we can see the maximum period in the contour and the associated significant wave height. So, to identify potential sites of a wave energy resource and to develop this activity, you have to take in mind two main goals. First one consists in provide a quantitative database to identify these optimal zones for future deployments and operations. This was done in 2016. That consists in wave energy potential assessment along the West Coast, that we studied the seasonality, directionality, and others, for then accomplish with the second steps that provide a reliable assessment of the environmental observations in this zone. Well, this was done here in this paper and are using a form contour approach. Final section. So to conclude, the environmental contour approach are performed to obtain the sea wave contour in 3 points of West Coast of Fuerteventura. These points are considered a hotspot of energy production and presenting a small variability in average terms. The procedures are well defined and well applied in the literature for this task, and we follow the recommendation by standards and international guidance for this task. The shape, or better, the form of the contour can help us to predict the future extreme combinations and can be used as structural safety or unsafety boundaries. These points also can be used to effectively design wave energy converters in the structural sense. And for Fuerteventura case, when you take account the lives today are related to the energy demand and consumption, the marine energy are crucial for the future due to the potential energy supply over the years. Moreover, can alleviate the energy demand for freshwater desalination power plant that represent today a local demand energy problem. For future works, we plan to test and perform some device available in the market today for these points in these conditions, these design conditions computed in this work. And I think I finished. Thank you very much for your attention.